question 17, quartz consists mainly of a compound with the following structure. Which of the following is not likely to be a physical property of quartz? So if you look at the diagram, right, this should remind you of diamond. Okay, it has a similar tetrahedral arrangement as diamond. So based on this, I can conclude that quartz is a giant covalent compound. Okay, the answer for this question, right, is actually option C, low melting point. Why so, right? Because for giant covalent compounds, under physical properties, they have a very high melting and boiling point. Why is because, okay, I'm going to explain in terms of structure, attraction, and energy, SAE. For structure, giant covalent compound. Okay, for the attraction, right, there is an extensive network of strong covalent bonds between atoms. Therefore, you would require a large amount of energy to overcome and to break all this extensive network of strong covalent bonds. So for quartz, right, since we know it's a giant covalent compound, we should expect to have a very high melting and boiling point. Okay, let's look at option D. Why is option D not the answer, right? Unable to conduct electricity. So if you look at the structure, okay, of this quartz, the shaded one represents silicon and the unshaded one is oxygen. Okay, silicon, right, is in group 4, which means that it has 4 valence electrons. And if you look at how many covalent bonds does each silicon atom forms, it forms 1, 2, 3, 4. Which means that out of the 4 valence electrons, all 4 of its valence electrons are used to form 4 covalent bonds with 4 other oxygen atoms. Okay, which means that there is no available valence electrons to act as mobile charge carriers. So therefore, for quartz, right, it is unable to conduct electricity. Okay, so it is a true statement. It's a physical property of quartz. That's why option B is not the answer. Now for option B, quartz is also very hard. How to explain if, let's say, this is a structured question? Okay, we can see that there is extensive network of strong covalent bonds. Okay, so based on the diagram, right, all these dashes that you see, okay, all this represents the strong covalent bonds. So with this extensive network of strong covalent bonds, okay, the layers of atoms cannot slide past each other easily. So that's why quartz is very hard. Okay? The covalent bonds are not easily overcome. So option C would be the best answer. You would expect a very high melting point as a physical property of quartz.